The NEURIM clinical trial was designed to show the principal mode of action of Neurexan by evaluating its impact on multiple brain functions such as the stress response, emotions, attention, vigilance, and the brain at rest and during tasks. Neuronal activity in the brain was measured by fMRI and EEG. Different assessments, including heart rate variability, blood pressure and pulse rate, as well as biomarkers in blood and saliva, provided further insights. Patient-reported outcomes were also analysed using questionnaires. The study population consisted of 39 men with mild to moderate stress levels reflecting common everyday stress who were otherwise healthy. Only male participants were included to exclude gender differences, which is common for stress studies. NEURIM was a randomized, placebo-controlled crossover trial, meaning that the group who received Neurexan at day 1 crossed over after a washout period and received placebo at day 2, and vice versa. This crossover design, with about 40 subjects, has the same statistical power as approximately 160 subjects in a parallel group design. Additionally, each participant serves as their own control by comparing Neurexan and placebo in the same person. Each participant underwent multiple procedures on each of the 2 days, including psychometric assessments, resting brain scans, as well as 2 EEG and 3 fMRI tasks. Multiple psychometric tests were assessed to evaluate general states of anxiety and mood, amongst other aspects. The 3 resting state measurements were conducted at baseline, after drug intake prior to any stress induction, and after the stress task. The 2 EEG tasks, AMST and oddball, took place after intake of Neurexan or placebo. In the AMST, or Attention Modulation by Salience task, the participants had to discriminate between 2 tones, while passively observing distracting pictures. Assessed were behavioral outcomes such as reaction time, electrophysiological outcomes such as brain waves, and the correlation of both outcomes. Both the AMST and oddball task helped evaluate whether Neurexan reduces susceptibility to distraction. The fMRI task started with the Hariri task, followed by 2 others, expectancy and scan stress. During the Hariri task, the participants had to match the different facial expressions, negative, positive, and neutral emotions, or geometric shapes, with a reference. With this test, investigators measured Neurexan's effect on regulation of emotions and stress response. In the second task, the expectancy task, participants viewed emotional pictures with or without prior visual cues. Investigators could then see how Neurexan influences the anticipation of emotions and stress. During the third task, scan stress, the participants had to perform arithmetic tasks and mental rotations, both under time pressure and with researchers rushing them. This test helps determine whether Neurexan reduces the burden of acute psychosocial stress represented by social evaluation, potentially leading to an improved performance under stress. Forming the basis for several publications, the results of the NEURIM trial contribute to better understanding Neurexan's mode of action, as well as physiological and clinical effects.